So, fact of life has just been learned, and that is nobody's perfect. Sorry. Again, I hate to be the bearer of bad news. So, we need to talk about how to fix your imperfections. Can we minimize those imperfections? Can we put some makeup on them and make sure that they're not really there? Can we make it look prettier? Can we go and maybe to the dermatologist and have a facelift to fix those nicks and tucks? That's what we're going to try to accomplish throughout the statistics lecture portion. So we talked about this idea of error. You have error, the measurement has error, the glassware has error, the instrumentation has error, everything around you has error associated with it. Just to give you an example, let's say that I take a volumetric flask in the lab, and this volumetric flask is 100 milliliters. Well, it's not a 100 milliliter flask. Ha 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 ha! We lied! It's not 100 milliliters. It's not exactly 100, or who are you fooling? This volumetric flask was made by someone or something, and it was shipped to us. And we get this volumetric flask off of our shelf, and we begin to use it. We assume, there's another, that word again, assume, that volumetric flask is 100 milliliters exactly. But it's not. There's no way possible it's 100 milliliters exactly. On the volumetric flask, after the 100 milliliter stamp, you will often see a plus or minus that is listed on the flask. And let's say that this is a plus or minus 0.02. Let's say that's what's stamped on there. That is letting you know that this volumetric flask is not 100. No way it can be 100 perfectly. But it's 100 plus or minus 0.02 milliliters. So that means it could be 99.98 through a window of 100.02. You take 100 minus 0.02 and you take 100 plus 0.02 and you get this window that this volumetric flask is in. That is one way that we can report errors. This is an error that's on our glassware. It's not 100 perfectly, so that means if I'm making standards, my standards rely on me using accurate volume. That accurate volume will change slightly depending on the volumetric flask. That is why it's always best to make standards out of the same volumetric flask, because this error that you are getting will be replicated, and it will be the same for every standard that you make, and your calibration curve will be much better versus someone that uses maybe 5 different volumetric flasks. So when I make standards, I typically take one volumetric flask, make my standard, dump it into a container, put a lid on it. Take the same flask, rinse it out, make my second standard, make it, put it into a container, put a lid on it. That's always the best option for you to do if you want to minimize errors that are happening along the way. Alright, so this is an error that's with our glassware. We have errors as well. Now, when we start talking about the errors, there's two different categories that we can talk about. Category 1, my first type of error, is something called systematic. And category 2 is what we call a random error. Okay, so a systematic error. Let's talk about it first. What is a systematic error? Well, this is maybe something like the glassware, right? This is an error that the glassware has. This error is going to be built into my solution prep. There's no way around it. It's going to be there. If I use this flask over and over and over, this is a systematic error. That means it's happening all the time. So glassware or instrumentation can be a source of systematic error. It is a number. It's not really true. It's happening every time I use that piece of equipment or every time I use that piece of glassware, and there's no way around it. This also could be a design in the experiment. Okay, so that basically means if I'm given an SOP to go by, and I'm reading the numbers of the SOP or the procedure, and I do what it tells me, what if that SOP has a wrong step? And I do that step every single time with every single sample. That is a systematic error. It's happening over and over and over. So we often call these systematic errors. They are reproducible. So, in the end, they typically wash out. Now, what does that mean? Well, if I do the same error every single time with my standards, and I do the same error every single time with my samples, in the very end, when I compare my samples to my standards, it's almost like nothing ever happened. I will probably end up getting a right result. I'll probably end up getting a legitimate number. That's the good thing about systematic errors. We know that they are there. We know that they are going to happen, but we also know that they are reproducible and they will happen every single time. And if they happen every time, then in the very end, typically our numbers are not affected by that. Okay, so not every time, but a lot of times they do wash out, and that's what we refer to that as. Okay, what about random? Well, a random error is just basically a screw up. I mean, that happens. So I'm in the lab, I'm measuring something out, and I wrote down the wrong number. That is a random error. I'm in the lab, I get the wrong size volumetric flask, I don't catch it. That's a random error. I'm in the lab and I choose a compound and I go to the stock bottle and I get the stock and I go over to the lab bench and I begin to use it. I picked the wrong stock. That's a random error. Well, random errors can also happen to instrumentation as well. So random errors for instrumentation would be something like, okay, well, I put the sample in the instrument. I told the instrument to inject a certain volume of sample. Maybe that needle that injects the sample is stopped up, or maybe it messes up that one random time. So that's a random error. All the other times it was okay, but just that one time something happened, and it didn't really inject the same amount that it did every other time. So that's a random error, and out of the two, random errors are harder to see and they are harder to fix. It's really hard for me to pinpoint where I went wrong. Sometimes it's a little easier than others, but overall, random errors are more complicated to fix and to report. Hence comes the idea of statistics. Statistics help fix the random errors that will go on in a laboratory. And this is why we have to go through the statistics portion of this course, because this is my way of ensuring GMP and GLP, and this is my way of feeling really good about the data that I am doing in a laboratory environment. Okay, so more about errors in the next video. I'm stopping here. So go take a break, go potty, come back with a cup of coffee, and then we'll pick up from there.